Oh, it was as easy as that. Okay, so we might not actually get to that worksheet. Everything, the entire class, I mean, truly probably 40 minutes, 45 minutes is going to be going through these 6 questions really slowly so you understand the concept, all right? So today we're starting rational functions, all right? And we're not necessarily going to start rational functions with graphing. Does anybody remember graphically what a rational function looks like? We're not going to start it with graphing, but do you remember what it looks like? Anybody with their hands? It looks like this. And it has this vertical asymptote right here in the middle, okay? Because of something called domain restrictions, all right? If you remember what the function is, it's 1 over x, right? The parent function. And the restriction is you can't divide by what? No, you can divide by 1. What mathematically can you not divide by?
0.
0, okay? So notice, if x were to be 0, you'd be dividing by 0, okay? So that's why when x is 0, you have this vertical asymptote there, all right? That's going to be tying into what we're doing a little bit later, and I'll explain that when we get there. But we're going to start off by just adding, subtracting, multiplying, and dividing rationals. Now, what makes this so difficult for everybody, by the way, and it really is 90% of you, is because we are adding and subtracting, multiplying, and dividing fractions. And you guys are not good with fractions. Okay? So let's start talking about just the basics of how multiplying and dividing, those are the easiest. Adding, subtracting, a little bit more difficult. Let's talk real quick about multiplying and dividing. If I have like 1/2 times 3/4. 1/2 times 3/4. How do you multiply those two fractions together? Straight across. That's why multiplying is very easy, okay? You don't need a common denominator. You don't need anything like that. You just multiply straight across. So 1 times 3 is 3. 2 times 4 is 8. And there it is, okay? Now let's make it a little bit more difficult, something that you might see in this situation, right? Could you imagine if you're multiplying these things? So it's not that bad, though. It's just x plus 3. I'm just making something up. 2 times x plus 3 over x plus 5 times, let's say, x plus 6 over x minus 4. That's just fractions. You're just multiplying fractions. And how do you multiply fractions? Straight across. Okay, so it really isn't any more complicated than just saying, okay, that's 2 times x plus 3 times x plus 6 divided by x plus 5 times x minus 4. Does that make sense? It's just all multiplied together. So multiplying fractions, really easy. Any questions on multiplying fractions?
Well, like for that, would you have like we ended up like would you have to turn it into like standard form? Or
That's a great question. So our question was, with this, would you turn it into standard form? You could, okay, and it would still be the right answer, but this is more beneficial in my opinion. Okay, and let me explain why. So we talked about real quick. That was a great question. I'll answer this question now. I was going to answer it probably later. We talked about the parent function of a rational is 1 over x, and because of that, you have a domain restriction when x is 0. So your graph looks like this, right? And you have a vertical asymptote on x equals 0. So if you leave it where it's factored, the benefit of this is it tells you, first of all, where your vertical asymptotes are. Okay? So for example, if x equaled -5 here, what's -5 plus 5? 0. -5 plus 5 is 0, and then -5 minus 4 is -9. But 0 times -9 is 0, and you'd be dividing by 0. So what that means is when you graph this, x cannot equal -5. So at -5, x equals -5, you're going to have a vertical asymptote. And at x equals +4, you're going to have a vertical asymptote, right? And I can definitely tell you that you're going to have vertical asymptote here and here. And your graph will look something like this. Like that, and then it'll come this way, do that. Something along those lines, okay? But those are the vertical asymptotes. And your ability to factor, which is why we just came out of the factoring unit, right? I told you if you can factor, it's going to help you significantly on this unit. And I told you that this unit depends heavily upon factoring, right? So once you factored it, that tells you where your vertical asymptotes are at, right? I told you we're not going to get too much into graphing yet. We're just adding, subtracting, multiplying, dividing. Here's another thing graphically, though, and the benefit of factoring. Sometimes, if you're factoring and say you had like if that's x minus 4 here, and this were an x minus 4 up there, they actually cancel. So your final answer would be 2 times x plus 6 over x plus 5, right? So, and if they cancel, let me explain this. If they cancel, you create something called, and we're not graphing yet, but graphically, a removable discontinuity. It's called a hole. There's going to be a hole in the graph, infinitely small hole right there. If it doesn't cancel, that's what you're going to have a vertical asymptote. Okay? So factoring and leaving it in a factored form is very beneficial. All right? So if you say multiply it out to get standard form, you can. All right? But it's more beneficial, in my opinion, to leave it in a factored form. All right? Okay, so let's keep going with that. So multiplying, you multiply fractions straight across. Okay? Dividing fractions, if you can multiply fractions, you can definitely divide fractions. It's very easy. So here it is. 1/2, instead of multiply, we're going to divide by 3/4. Okay? How do you do it? You multiply by the reciprocal of what you're dividing by. Okay? So if I take this and flip it, it becomes a multiplication problem. And if you know how to multiply, then you know how to divide. That's what I'm saying. So 1/2 times 4 over 3 is the same thing. So division really is the exact same thing as multiplication, except you just need to flip it, and then you're multiplying, right? And how do you multiply fractions? Straight across. So it's 4 over 6. Does that make sense? Huh? I mean, yeah, you can simplify it, but the concept still remains, right? That's how you divide. Now let's make it look a little more complicated again by, actually putting some variables in there. So if I have, let's use that 5 times x minus 5 divided by x plus 3. And then let's do all that divided by 3x over, let's do 2 of them, x plus 2 times x plus 3. Now, if you realize dividing fractions, these are just fractions, right? And dividing is the same thing as multiplying by the reciprocal, right? Then this is simply, and you don't have to write any of this down yet. What I want you to write down is when we start actually working these problems out, okay? But multiplying by the reciprocal would look like this. Y'all understand that? And you multiply straight across. Now think about this. If you're multiplying straight across, do you understand if I were just to write that? Do that. Just make it one big line. So you have 5 times x minus 5 times x plus 2 times x plus 3, right? And on the bottom you have x plus 3 times 3x. And it's all just multiplied together at this point. Yeah.
So when you took out the x plus 3, so it's just one on the bottom and one on the top.
Perfect. Yeah, that's what I was getting at. Perfect. So he said, so when you take out the x plus 3, since there's one on the bottom and one on the top. Yep. And graphically, right, if you were graphing it, it would create an infinitely small hole in your graph. Removable discontinuity when they cancel like that. You have a vertical asymptote at x equals 0. Okay? So we're going to get into the graphing later, but I'll just continuously kind of point and reference what that would look like graphically. So when you get to graphing, you'd be like, wait, isn't that a removable discontinuity? Right? And you already kind of know some of the concepts because I've been putting them in your mind for the last week and a half. Okay? Does that make sense though? Okay, so that's dividing and multiplying. Those are the easy ones. Adding and subtracting, that's where people get really messed up. Okay? So the reason is when you are adding fractions, plus let's just keep using the 3 over 4. When you're adding fractions, you need a common denominator, right? And you guys know that. So if you're going to get a common denominator, you need to find the least common multiple between 2 and 4. So what number does both 2 and 4 go into? 4. Okay, so this one's already at a denominator of 4. How do I get this one to be a denominator of 4? Okay, multiply by 2. That's what everybody said just now. Now here's the problem. I'm just giving you the concept. I think you guys understand this, but realize, don't just be memorizing what to do, understand it. Do you understand that I just can't multiply by 2? You can't just multiply something by 2. I'm making it twice as big if I do that. So what mathematical number do I multiply by to keep it the same value? 1, right? Multiply by 1. Okay, so 2 over 2 is 1, isn't it? 2 divided by 2 is 1. So 2 times, we already know how to multiply fractions. 2 times 1 is what? 2, and 2 times 2 is 4. Isn't 1/2 the same thing as 2/4? We didn't change the value of anything, right? We're not changing the value. You can't do that mathematically. If you want to check your work, just period. This is a great rule to remember. If you want to check your work, make sure you're not changing the value of anything. Make sure you're not just randomly multiplying by 2. That's why in Algebra 1 they said, hey, what you do to one side, you have to do to the other to keep it the same value, right? Because if you just do it to one side, you're changing the value, right?
So the next, equal sign, don't you put it
Plus 3 over 4. No, because 2 over 2, we multiplied 1/2 by 1, so we didn't actually even change the value. Okay? So now you have, and this is another misconception. What is 3/4 plus 2/4? 5/4, right? Imagine like cake. If I have 2/4 of a cake and I have 3/4 of a cake and I add them together, I have 5/4, right? A lot of people think they're adding the denominator as well. You don't. Once it has a common denominator, it just stays. Okay? And that makes sense. Think about it like cake. If I have 2/4 of a cake and 3/4 of a cake and I add them together, I have 5/4. Okay? I don't have 5/8. The pieces don't all of a sudden become eighths. Does that make sense though? The denominator stays the same. So your objective, get the denominator to be the same, the common denominator, so you can add or subtract across the top. All right? Now, with subtracting, real quick, let me just give you an example. Whoops. And let's erase that, erase this. I'm going to just make this a little bit longer, and there's a reason I'm doing this. Say it was 3 plus 6 over 4, like this, minus 3 plus 6 over 4. The reason I'm telling you this is, here's another mistake people make. Before I even tell you what it is, what do you think I'm going to get at right now?
You add the 3 and the 6.
You could. That's fine. That's actually a really good idea. He said you add the 3 and the 6. Okay? But, I mean, even more practical to what you're going to be doing in a second. Did you have a guess, Emily? No? Look, the negative goes onto the 3, and the negative goes onto the 6. So you have negative 3 plus negative 6 is negative 9. So what Mauricio just said is you add the 3 and the 6, which is 9, then make it negative. Notice both ways would work, right? Which would be negative 9 also. That's another mistake that people will make. Okay, so what we just talked about, multiplying fractions, you just multiply straight across. Dividing fractions, you multiply straight across by the reciprocal. Okay? Adding, subtracting, common denominator, so you can either add or subtract the numerator, right? Those are the basic concepts. Now let's start going with this. This is what I do want you to write down. Don't write down this. Write down this. Write down that. Okay. Now here's why I wanted you to write that down. I want to get this point across. I want to show you what the benefit of factoring is. One benefit, okay? When you look at this, before you can subtract these fractions from each other, you need a common denominator, right? Okay, what's the common denominator between, if you had no idea what this was, right? Realize that is coming from that, right? But if you had no idea what that was, and you didn't know how to factor, what's the common denominator between x minus 5 and 5x minus 25? Well, you guys are seeing it probably because of this, okay? But later on, it becomes really complicated to see something like that. Like, what is the least common multiple between that and that, right? Now, because of factoring, we factor anything, all right? And we have 5 times x minus 5. So the question now is a lot easier. What's the left side missing that the right side has? Just 5. It's just missing 5, right? So if I want a common denominator, then I simply need to multiply by 5 over 5. Does that make sense? And just so you know, guys, and it's happened in the first two classes so far, it's confusing at the start, starts clearing up a bit here, clears up a lot here, and then you start doing number 5 and 6 totally on your own, about 75% of the class, okay? So you keep paying attention. All right. Does this make sense, though? You needed the 5. So that was the benefit of factoring. You look at the denominators, you say, okay, this side needs the 5 still. So you multiply by 1, 5 over 5. All right? So now simplifying, you end up having, let me erase this. And you guys can write this all down in a second. Don't write it down now. I'll give you time. How do I subtract, real quick, 5x minus 3? So let me write this out. Yeah, 5x minus 3 minus 4, now that I have the common denominator. Plug in. What do you mean plug in the 5? Distribute, exactly. So before you can do that, you've got to distribute this. So you have 5x minus 15 over 5 times x minus 5 minus 4 over 5 times x minus 5. And notice we have the common denominator, right? We distributed the 5 into this factor up here on top, that binomial. We're good there? Okay, and now it should be pretty clear. We have the common denominator, so we can subtract straight across. So our denominator is going to be 5 times x minus 5. Remember, you don't add or subtract the denominator, you just write it like that. And then 5x minus 15 minus 4 is what? 5x, what is it? Minus 19. Does that make sense? And that would be the final answer. All right, any questions on that? Yep.
Why didn't you multiply the 5 to the negative 5? Like you multiplied the 5.
This right here?
Yeah.
Well, I mean, I didn't multiply the denominator at all because I talked about...
You're trying to get it the same?
Yeah.
Okay.
And the benefit of having that denominator, remember, the reason I don't multiply this out is because I know exactly where the vertical asymptote is at this point, right? Now, some of you who are pretty intuitive might be able to see this right here. 5x minus 19 divided by 5 times x is 5x. 5 times negative 5 is negative 25. And here's where a lot of people get mixed up. So with practice, you'll understand this better. But a lot of people think that they can cancel out 5x and 5x. Okay? But you can't. All right? I'll explain. I'll show you, I think the best way to explain it is show you an example where you can cancel things out and an example where you cannot. Do you see how everything is not being multiplied together? That's why you can't. All right? So for example, this is actually the same thing as 5x divided by 5x minus 25 minus 19. Notice I'm just splitting the 5x and the 19 divided by 5x minus 25, okay? That's what that actually is. So you can't just go, you still have to deal with this minus 25 part, okay? Now, what you can do, say, oops, we'll get rid of that too. All right, say you had maybe 5x minus 19 times x minus 3 over 3x plus 2 over x minus 3. Now that it's factored, everything's being multiplied, right? Now you can cancel that and that. All right? So as you guys work these out, you'll get more familiar with that. All right, are there questions about from here all the way through there? All right, if you want, go ahead and write that down. How many people need time to write it down still? Okay, go ahead. Make sure this thing is still, yep. Okay, still need time or are we good? All right, so here we go. Next one. Common denominator, first question. Before I add these, I need a common denominator. Are they the same? Okay, so let's see how well you guys understand this now. Now, this would be making a jump. I don't expect anybody to get this really. One person got it first period, second period, nobody got it. How do you find a common denominator here? Good question. Good assumption. So you're saying like something like 6?
Yeah.
That's a good assumption, but no.
Just multiply it.
Huh?
Multiply it.
Multiply each other? Yeah, pretty much. I mean, I don't know exactly what you mean by that, but yes. So for example, if you simplified and you have no like terms or anything like that, you're just going to simply multiply by x plus 3 divided by x plus 3. And that is 1, right? X plus 3 divided by x plus 3 is 1. And then on the left side, I'm going to multiply by x minus 2 over x minus 2, which is 1, right? But look at my common denominator. You multiply fractions straight across. My common denominator is going to be x minus 2 times x plus 3. Do y'all see that? Both fractions have the same denominator now. So the common denominator, x minus 2 times x plus 3. Okay? Now, pay attention. This is the way I think about it, by the way. You could write it like this. You could very easily write two separate fractions. X minus 2 times x plus 3. Let's go ahead and do it this way real quick. So what you're going to end up having is this distributed. So that's negative 3x plus 6. This one's going to be 4x plus 12. Right? Y'all following that?
Yes.
But it's a common denominator. So really these are just all being added together. It just comes down to combining like terms at this point. Right? So my final answer is just going to be x minus 2 times x plus 3 in the denominator. And then on the top I have negative 3x plus 4x. Yep. 6 plus 12. And that'd be the final answer. Okay, you guys got it? So what I'm saying with this is I don't actually even write that step down. I'll show you an example of me not writing that step down next time on the next problem. So you can go ahead and write that down. And as y'all are writing it down, does anybody have questions? Hold up.
Why did I switch the x minus 2 to multiply the other one?
Which part? Here or here?
That one right there.
This one?
Yeah.
Because they had nothing in common, right? So the least common multiple was literally you have to find it by multiplying them by each other. So x plus 3 over x plus 3 on this side, x minus 2 on this side. So now our common denominators, notice, are x minus 2 times x plus 3 and x minus 2 times x plus 3.
So they won't cancel out, right?
Right. Okay. Huh? What? You can after we get to number 5. Okay. Everybody got this one? All right. 3. Again, common denominator. Is there a common denominator right now? No. Okay, so what do I need to multiply the left side by and the right side by to get a common denominator? Okay, so 3 divided by 3 on the left.
Does that work every time? Or?
It does work every single time. Sometimes you create more work than you have to, right? Than you need, but it works every single time. If you take the denominator here and multiply it y squared minus 4 over y squared minus 4 and then y plus 2, that works. If you really want to take that denominator and multiply it over here, right? X squared minus 3x minus 10 over x squared minus 3x minus 10 and then x minus 5, that'll work too. But as you can see, sometimes that is super complicated and it just puts a lot of variables everywhere. So I'll show you better ways of doing it in a second. But yes, it always works. Okay, everybody good here?
Yeah.
So I told you that I'm going to skip that step this time. This is how I think about it. What's my new denominator?
B minus 2.
3 times b minus 2. Exactly. Okay. 3 times b minus 2. Now, up top, and this is what I'm saying, I don't even bother writing the two fractions. I realize that because I have a common denominator, they're going to be added together. So up top I have 3 times 4b, which is what?
12B.
12b. Now, keep in mind that that is a negative. So I have negative 1 times b, which is what? Negative 1b, right? Negative b. Oh, that looks awful. Okay, negative b. Negative 1 times negative 2, which is what? Plus 2. Okay, combining the like terms, which you can do already in your mind, but I'll just do it one more time. 12b minus b, 11b plus 2 over 3 times b minus 2. You guys getting it?
And that's it?
That's it.
How come you don't, like, distribute the 3?
You can. That's what I've said that. So the question was, how come I don't distribute the 3? Okay, you could. 11b plus 2 over 3. Let's distribute it. So this and this. 3b minus 6. Okay, I distributed it, but from here, that's just as right as this, by the way. Okay, no answer is more right than the other. But this one, I know exactly where the vertical asymptote is. It's at b equals 2. Okay. Also, if I happen to have something up top, so for example, if this was like, say that was positive, and I had 11 times b plus 2, then I could cancel that and that, right? So leaving it in a factored format is more beneficial. Okay, we're good on that?
Yeah.
So how are you guys, are you catching on some?
Yeah.
Okay. Number 4. Factoring, right? This is beneficial. This is where it starts becoming beneficial. So Maddie asked a second ago, does it always work to multiply by y squared minus 4 over y squared minus 4, y plus 2 over y plus 2? Yes, it does. But because we factored, and this is why we just did that, you should recognize this as being what?
Difference of squares.
That's a difference of squares. Exactly. That's a difference of squares, which means it actually factors to be like this. 2y over y plus 2, y minus 2. Ooh. Okay. And then plus 3 over y plus 2. So the question is, first, simple question, are they the same denominator? No. What's the right one missing that the left one has?
Y minus 2.
Y minus 2. So that's what you're multiplying by. Just y minus 2 over y minus 2. Does that make sense? Yeah. So that's it. So now you just simplify. So again, the way my mind works, I already know the common denominator. What's the common denominator? Y plus 2, y minus 2. Up top, I still have the 2y. We didn't do anything over there. And then I have 3y. And I have 3 times negative 2.
So would it be 5y minus 6?
Yep.
And can't you put y squared minus 4 at the bottom, or is it right there?
Good question. Okay, so that combines to be 5y minus 6. Question was, can you put y squared minus 4 at the bottom? Yes. Mauricio, can you answer that question?
What?
Because I just answered it for you. Like, why would I not want to multiply that out?
Oh, because you can tell the asymptote.
Yeah, there's a vertical asymptote at negative 2 and positive 2. Okay? Now, with that being said, let me show you something. On your worksheet. You don't have to turn your worksheet over. I've got it right here. So you just look up here. If you look at number 19. All right. Now this will be beneficial for you guys because you can actually see the whole thing worked out. Number 19, it starts off with this. Notice there wasn't anything that I could factor, so I multiply by x plus 7 over x plus 7, x minus 3 over x minus 3, right? My new common denominator is going to be x minus 3, x plus 7, right? I have 3 times x, which is 3x, 3 times negative 3, negative 9. 4 times x, 4x, 4 times 7, 28, right? Okay, we have a common denominator, so I'm just combining like terms. So I have 7x, and I have plus 19 over that, right? So I have a vertical asymptote at x equals 3 and x equals negative 7. That is true. Now, you'll see the answer in the bottom where it has all these answers at doesn't look like that. Yeah, so the way I was doing it was I was just looking at all these options for answers. It's like, okay, well, which one has 7x plus 19 on the top? 7x plus 19. But it's divided by x squared plus 4x minus 21. So I guess I didn't do it right? No, they just multiplied it out. Okay, it's the same answer. X times x is x squared. Negative 3 times 7 is negative 21. Negative 3x plus 7x is 4x. Okay, it's the same answer, but this one's more beneficial because you know exactly where your vertical asymptotes are. All right? You guys got it? All right, any questions so far about anything we're doing? All right, so we just worked this one right here where you had to factor to find out what you can multiply by, right? To get a common denominator. So on number 5, here's a trinomial. That was a binomial. So remember, binomials, difference of squares, sum of cubes, sum of squares, or sum of cubes, difference of cubes, right? Any of those. That was a binomial. This is a trinomial. A value is 1. So find two numbers that multiply to be negative 10 and add to be negative 3. Factor it so you can find out what you need to multiply the right side by so you can have a common denominator. Add it all together. See if you can get the right answer. See if you can do it on your own. I'll give you 3 minutes. And if you can do it on your own, awesome. I'll just walk around. If anybody needs help, let me know. So starting here, does anybody need help? Straight back. Need help? You guys good here? Anybody here need help? And you guys? You guys good here? Okay. Did you get it? Yeah. I think that should be a negative x, right? I think.
Yeah, it is, because x minus 2x.
Yeah, negative x. You want to go to the restroom? Yeah, I mean, if we have time. But yeah. Mhm. I'm glad you didn't. Awesome. Mm-hmm. Yeah. Good deal. Okay, if you're on the right track, you know what you're doing, go ahead and keep going. I'm going to pause the timer. I'm just going to go ahead and answer it right now. So if anybody's stuck, you can pay attention. If you think you got it, I'll show you the answer pretty soon. All right, so first thing, factoring this, you should have gotten x minus 5, x plus 2. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. Okay? So that's the same thing. All right, now from doing that, you're trying to get the common denominator, so you should realize that the right side is missing the x plus 2 factor, right? So you multiply by x plus 2 over x plus 2. And my new common denominator is going to be x minus 5 times x plus 2. So far, so good? Okay, top part, I have x plus 3. Be wary of that negative 2. So that's negative 2 times x, which is negative 2x. And negative 2 times 2, which is negative 4. All right, so combining like terms, I have x minus 2x, which is negative x. I have 3 minus 4, which is negative 1, all divided by x minus 5, x plus 2. So if you got that, you got it right. Okay. Second thing, if you decided you wanted to try to factor out a negative, this is also right. X minus 5. That's also right. Okay? And it actually just shows your attentiveness to that negative that you could actually pull that out. Now, real quick, I want to explain why that's so beneficial. check this out. If this were a x plus 1 right here, right, on the bottom, now we're just playing the if game, but if it was x plus 1, in this situation where you have negative x minus 1, it helps to be aware that you can always pull that negative out, but you wouldn't be able to see that they would cancel, right? If you knew that you could pull the negative out, if you're good with manipulating algebraically, that does cancel, right? And the final answer would have been like negative 1 over x minus 5. X minus 5, which means there would have been a, graphically speaking, right, a removable discontinuity or an infinitely small hole in your graph right there, right, like I talked about at the beginning of class. And you would have a vertical asymptote at x equals 5, okay, and not at x equals negative 1. Okay, so make sure that if you're not good at this, you just need to be more attentive to algebraic manipulation, right? You can just simply multiply things out or sometimes divide them out, make them look a little bit different, and you can notice certain things. All right, any questions on this? How many of you got it right? Nice. So about, I'd say about 60%. Good deal. Well, I'm going to go ahead and stop this recording, but why don't you try to work number 6? And I guess just for the sake of the recording, I'm going to write the answer up there. You guys don't have to look necessarily.